Hi, I'm Neeraj Murarka, CTO and co-founder of Bluzelle. And here's Monty, who's going to be doing our demo for Sprint Highlight number 49.
Hi, I'm Monty Thibault. I'm a developer here at Bluzelle, and what I'm going to be demonstrating today is our new HTTP API that enables smart contract developers to use Bluzelle in their applications. So our central documentation is here at docs.bluzelle.com, or you can go to bluzelle.com and hit tech documentation. The HTTP API is here under this page, Solidity Support, Bluzelle HTTP API. And here I have a link that shows all of the HTTP functions that you can use. So these functions include the basic create, update, read, delete functionality, as well as time to live functions, where you can create a key with a certain lifetime and have it expire after a set number of seconds. So let me just demonstrate how you can use these. I'm gonna hit this button that says try it out, and I'll enter the arbitrary name of a key. I'll say my key. And then I need an arbitrary name of a value. Let's say my test value. I will hit execute. Now in this time, it's going to go, it's sending a request to http api.bluzelle.com/v1/create/mykey, and the post body is going to be the value of the key. So you can see here that the response went through. It has a code 200, meaning that it was successful, and there's no response, so it went through. Now, if I want to read the key, I can go to the read function, and I'll enter my key, the same key that I entered in create, and I'll hit execute here. After just a moment, it's going to respond with the value of the key, and you can see that it's a code 200 again, meaning that it's been successful, and the response body is my test value. So using this HTTP API, we're going to be able to integrate it with our Solidity smart contracts using Provable. So let me just demonstrate how that happens right here. This is our smart contract. We're importing the Provable API wrapper, and then we have some functions here. The main logical flow is that you have two functions, a create and a read. The create function calls to the Provable oracle this HTTP request to Bluzelle, and we're creating a key called mytest123 with hello world value. And then the read one sends a key, it sends a read request to mytest123. So we're just creating and reading keys, and then it'll call this callback function, and we're going to see in the smart contract what the values are that are being returned. Are there any questions so far?
Yeah, I have a question. So if I'm a DApp developer and I want to use this Bluzelle smart contract to talk to, the database off chain, do I need to sign up for something to do this?
No, you don't have to sign up at all. So some APIs mandate the use of an API key. We don't require that. So here in our API, you can see that I just went on my web browser and I went to the documentation here, and I was able to call these functions without any further configuration. So it's really usable right out of the box, and you don't need to do any configuration beyond that.
Okay.
So the next part of the demo is going to be actually demonstrating a real-life Solidity smart contract using these functions and getting data out of the Bluzelle API. So I have a contract that's already been published here, and I'm going to run the create function, which is going to create this key, mytest1234, with the value hello world value. So the first thing is that I'm going to have to send them some ether. This is on the Robston test network, by the way. So I'll send them 0.1 of an ether, and I'll just run the create function and confirm the transaction here. So here in the Etherscan contract window, you can see the contract creation that occurred several minutes ago. And in just a few moments, we'll see the request that we're sending out.
Okay, so the smart contract we just looked at was pre-deployed, and now you just did a create on that smart contract that went through Provable to Bluzelle and came back with a response at some point.
Yes, yes. So if I refresh this page, you can see 1 minute ago, you might have seen the notification in the corner of my screen. This was our outgoing request to Provable to create the key.
Got it.
Okay, so the transaction has come back. So you can see the one transaction 1 minute ago. Then 42 seconds ago, we get a response. And to see what happened, I'm going to go into the events tab here. and decode it. So this is our outgoing message. And it says to us, the provable query was sent, standing by for an answer. And then the message that it was responded to is an empty message. That means success. Nothing went wrong. So now I'm going to go back to the smart contract and do the same thing, except now I'm going to read the value. Instead of the first one we're creating it, now I'm going to read. So this is going to send me to MetaMask again, and I'll confirm my Robston tokens. And then we'll wait again to see what the result is.
So now you're sending off the read request, and Provable will receive that, get the response from Bluzelle, send it back to you as an event.
Yes, exactly.
Okay. Now, while we're waiting, can we use this for complex applications?
Yes. So the example that I've shown here is really a very simple, basic example. It's just creating and reading a key, but it's highly, highly extensible. First of all, you can use any of the HTTP functions that we specify in our API here, including time to live values. And you can also embed these provable queries in arbitrary application logic in order to encode anything that you want to represent maybe off of the smart contract in a cheaper way, but you still want the smart contract to be able to access it. So it is highly extensible to complex applications.
Okay.
Now I'll go over here. I saw a notification, so I'll refresh the page, and you can see what's happened. There's one more transaction. This was our outgoing transaction, and then this is the response transaction. Let's go into the events and see what happened. First of all, I'll decode the outgoing message, which is that the provable query was sent and that it's standing by for an answer. Then here's the answer from provable, and I'll decode this. And it says hello world value. So this is, if I just encapsulate what happened, we called create. It created a key in the Bluzelle database with the value hello world value. And now it readed the value out of this second HTTP call. And then it's being logged, function call right here, log result.
Wow, that's amazing. So basically, you've demonstrated access to from Bluzelle from Ethereum with your what you built here using Provable.
Yes. So it's highly, highly extensible, and it works very well. You can represent data off chain with this and get it back whenever you need it.
Okay, that's really amazing. Well, thank you very much, Monty, for that great demo. And yeah, I look forward to getting members of the community to start using this as soon as we make it available to the public.
Okay, great. Thank you very much, and I hope you enjoyed the demonstration.